Warm welcome to all of you. Good morning, good afternoon, good evening to all my dear students and friends. This is the fourth lecture for DADM2, which is data analysis and decision making. And as you know, this course is for a total duration is 12 weeks, 30 hours. Each week we have 5 lectures, each lecture being for half an hour, and after each week we have an assignment, and then after the 12th week there would be a final examination. And my name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember that in the last lecture, which was the third one, we were discussing at the fag end in the last 2 slides about the concept of risk and how the properties of concept of risk could be analyzed. Risk means from the utility point of view. And we did mention, and I did discuss, one of them was the absolute risk aversion property, where the actual formula is given by minus of u double prime divided by u prime. And as you know, according to the 2 properties of utility analysis in a very simplistic form, I am not going to the detailed mathematical content. So, in the simplistic form, the 2 properties were non-satiation, which basically translated into the concept that the first derivative would be greater than 0. And the risk property would basically be divided into 3 categories. I love risk, I am indifferent to risk, I hate risk. Based on that, you will basically have the second derivative would be greater than 0. If I am indifferent, it will be equal to 0, second derivative, and in the last case it would be less than 0, the second derivative. So, for the absolute utility function, we divided the decision into 2 sets. One was w plus z, z was basically a fair gamble, where the expected value of z was 0 and the variance of z was sigma square suffix z. And on the other hand, you have basically had a total investment of w suffix c, and based on the concept of Taylor series expansion, we will basically derive the actual formula, which is given by minus u double prime divided by u prime. Now, if the person is indifferent between the decisions on the choice of A and the choice of B, then obviously if he or she is indifferent, then obviously the expected value for A, or which is on table 1, and the expected value of B, which is on table 2, or whatever case 1, case 2 we say, they would be equal. So, as it mentions the expected value, I will just highlight it once. So, the expected value of A is equal to expected value of V, and if you remember, for what was A was w plus z, and B, what was B? B was WC. So, if you basically put them, the actual formula comes out to be A is the left hand side, which I am highlighting now, and B is the right hand side, which I am highlighting now, or maybe I will just put a tick with respect to colors. So, it will be much easier. So, this is A, and if I consider B, this is B, that would basically be, and if you remember, the B was basically a decision which was certain. So, you have WC only and the probability would be 1. So, you multiply them and you get UWC depending on the utility functions functional form. The person is willing to give maximum of the difference between W and W minus C to avoid the risk. So, because if he wants to take one decision with respect to the other, whether he wants to take the risky one or or the certainty one. So, there has to be some counter payoff. Now, if we expand W plus Z, which is basically the risky one, W amount plus the fair gamble in the Taylor series expansion, we can basically get the terms where we can basically find out that A prime is equal to minus u double prime divided by u prime. Now, for the different 3 different types of persons which we have already discussed, if we just write down the rule, and we will come back to the using of the rules later on. So, decreasing absolute risk aversion property would mean that A prime or differentiation of A w with respect to w would be less than 0. For the constant absolute risk aversion property, obviously A prime would be 0, and for increasing absolute risk aversion property, A prime would be greater than 0. Now, what does this conceptually mean in a very simple practical sense? So, let us look at this table. So, on the first column we have the conditions, what is the condition based on which we are trying to pass on the judgment. Second would be what is the actual practical definition based on which we are saying that absolute risk aversion property or relative risk aversion property or the first derivative of absolute risk aversion property is greater than 0, equal to 0, less than 0. So, that would basically come under the column which is the second one, which is definition. And mathematically when we try to utilize this for our calculation for the examples. So, because obviously we will consider different type of utility functions, try to analyze the utility functions, what are the properties, whether the non-cessation property is met, whether the risk property is met, and obviously we will try to comment that what are those properties of the utility function based on the absolute risk aversion properties is a derivative, relative risk aversion property is derivative. Now, why it is important? I did not mention it, but I have been talking in the last class also, today I also mentioned that they are important. Why they are important? The reason is that technically finding out the exact form or some functional form of the utility function or knowing what type of utility function a person has is not possible. Because I may express my liking and disliking for a decision, but I may not be able to find out exactly whether it is a quadratic one or a logarithmic one or an exponential one or a power function one. So, what we do is that we use the properties of those utility function for which we do not know the functional form, use the concept of A prime A, R prime R, and then get some results based on which we can go backwards and say that yes, this utility function is quadratic, or else we say no, this utility function is not quadratic, it is basically logarithmic. So, we will come to that later on. So, this is the basic one of the main utilization of utility functions in our case. Now, remember if you go into the depth of utility function, is a vast area, we are not going to apply all this concept, we will keep it very simple in order to basically utilize how MCDM and MAUT, which is multi-criteria decision making and multi-attribute utility theory, will be utilized for our non-parametric decision making process in DADM2. So, coming back to the slide which is slide number 35. So, the properties based on which we will comment, the mathematical properties are given in the third column. So, let us go one by one row wise. The first condition which states is that decreasing absolute risk aversion property is true. Now, what does that mean in the practical sense? Which means that as the wealth of that person increases or as the total amount of so called investment in a decision increases, or whatever the decision variables are, if they keep increasing, then the amount held in the risky assets, I am using the word assets in a very general sense, is the risky decisions. Let us use the word risky decisions. So, the amount held in risky decisions or assets also increases. So, if that is true, then obviously it would mean that the A prime is less than 0, which we have already commented what it means with respect to loving risk, hating risk, or being indifferent to risk. I will come to that once again when we do the problems, please bear with me. Now, if we let us concentrate on the second row, it gives us constant absolute risk aversion property, which means as wealth increases. What I am reading now is basically the definition part in the second row. As wealth increases, the amount held in risky decisions or risky assets remains the same, and it means that the A prime would be 0. And finally, if we go to the third column, it means that increasing absolute risk aversion property is true, which means as wealth increases, the amount held in risky assets or risky decisions decreases, and in that case A prime would definitely be greater than 0. Now, you check the wordings in first column and the concept which is given in the definition in the second column. Now, let us go again back to row 1. It means decreasing absolute risk aversion property, that means my risk aversion property is now decreasing, which means that I will be more tempted to invest in risky decisions and risky assets. So, if that is true, then the definition part should also match with that, and let us read it again. As wealth increases, the amount held in risky asset increases, which is true. That means my absolute risk aversion property is decreasing, that means I am more willing to invest in risky assets or decisions. So, if you follow these principles in a very simplistic logical sense, in the wording sense, this comes out to be true for the first row, second row and third row, and we will again prove it that mathematically, which is the last column, would also be true as we try to basically solve the problems accordingly. Now, let us go into the other property which is known as the relative risk aversion property, and this relative risk aversion property and absolute risk aversion property would be utilized, as I said, depending on their results which we get for different type of utility functions, and we can comment what type of utility function it is. So, relative risk aversion property is given by the ratio where we multiply the absolute risk aversion property multiplied by the wealth. So, the final formula comes out to be minus w into u double prime by w u prime. If you want to differentiate it, remember that we will always have that u prime is greater than 0 as per the non-cessation property. U double prime can be greater than 0, equal to 0, less than 0, depending on whether I want risk, more risk, which is greater than 0, about second derivative of u. If it is equal to 0, that means I am indifferent. If it is less than 0, that means I want to run away from risk. Now, the sign of the first derivative of r would depend only on u prime, u double prime, sorry, because u prime is technically 0, greater than 0, and w, which is the wealth, is also the amount of wealth which I have in my hands, which is also positive. So, let us come back to the actual conceptual way how you try to analyze and find out what is the expansion of r prime and what is the actual formula which will be utilizing it, and how we derive r. Consider the same example as we have done in the previous case when we were considering the absolute risk aversion property. But now we consider that it is in the relative sense, not in the absolute sense, because in the first example it was the absolute sense or difference of the wealth which was being given to us, or we are considering that in order to prove that. So, basically we have the absolute ratio given as w minus wc by w. Now, remember that case 1 which is on the left hand side or on the table 1 and case 2 is on the right hand side which is on table 2. In case 1 we consider w as a wealth plus some amount which we are going to invest, for which the expected value of z was 0. It is a fair gamble and the variance of z was given by sigma square suffix z. On the right hand side we had a total amount of investment of wc. So, based on that we are proceeding. So, the context based on which we are trying to draw the derivation is exactly the same example as we did for the first case for A. Now, which is basically if you check into the ratio pi dash. So, this is w minus wc by w, which is a percentage of the money the person will give up in order to avoid the fair gamble, because the fair gamble, if you remember, the expected value in that case was 0. Now, we are considering the expected value as 1. So, I want to avoid the fair gamble, that means I do not want to take a risk, I want to go for the certainty event. So, per unit increase and decrease in my wealth, what is the total percentage based on which I will take the decision? I will run away from the fair gamble or I will basically go for a certainty event. So, that is basically what is the decision you want to take. So, Z depends the outcome per rupee investment or per dollar investment, and this is, if you remember, expected value of Z is 1 in this case. Therefore, for W investment we obtain an amount of W into Z, and on the other hand we have a sure investment of WC which is given on table 2 or case 2 or on the right hand side, if you remember we are discussing. So, left hand side, right hand side we want to basically balance, based on which you want to find out. We have found out A, now you are going to find out R also. For the investor to be indifferent between the two decisions on table A, table B. So, what we have is basically the expected value of the utility of W into Z, and why it is being multiplied, because now it is basically ratio. So, we can find out by multiplying and finding out the total commitment of the amount of money which you want to invest, and on the right hand side you have WC. So, that value should match. So, the expected value of both hand sides, left hand side and right hand side, should match. Now, consider the function of utility of u of W into Z expanded using Taylor series expansion. If you basically put the terms, then the functional form of R comes out to be minus W in the bracket u double prime divided by u prime, as we have already stated. So, this assignment word which is given is basically just if somebody is interested. This is nothing to do with the course. Remember that it will carry no marks. It has no implication for the assignments. 12 assignment is no implication for the examination. It is not counted, but people who are interested then just can check that how these proofs are done in order to basically get themselves acquainted that how these proofs are very simply done. Again I am mentioning this assignment 1 which was given for, I forgot mentioning that beforehand when we were discussing absolute risk aversion property, I am sorry for that. So, this assignment 1 which is given for A and assignment 2 which is given for R, absolute risk and relative risk, they have nothing to do with the course, they have nothing to do with the assignments, they would not come into the assignments, they would not come into the final examination. These are just to inculcate or bring up the inquisitiveness in you. If somebody is interested, he or she can definitely check. Now, in the similar fashion, we will basically follow the same logic as we did for A. For the 3 different type of person which we have, decreasing relative risk aversion property would mean that R prime, which is d of R w by d w is less than 0, constant relative risk aversion property would be R prime is equal to 0, and increasing relative risk aversion property would basically be R prime is greater than 0. So, now mark the words decreasing relative risk aversion, constant relative risk aversion and increasing relative risk aversion, and this would be coming back again, and I will try to explain the concept of relative risk aversion property increasing, decreasing and constant in the same context or the same type of explanation as I did for the absolute risk aversion property. So, with this let us come back to the same type of table which we have already discussed. So, in the table we have basically in the first column condition, in the second column definition, and in the third column the mathematical property. Now, I will start again, it is this the context or the overall concept of condition, definition, properties are exactly the same as we have discussed in for the table for A, which is absolute risk aversion property. So, the conditions which basically are given, let us go one by one in the row wise. So, decreasing relative risk aversion property means that my relative risk aversion property is decreasing, that means I am more willing to go for the risk. It means that as wealth increases, the percentage held in risky asset would increase, because my risk aversion property relatively is decreasing, and in that case R prime would be basically be less than 0. If it is constant relative risk aversion property, it would mean that as wealth increases, the percentage held in risky asset or risk decisions would remain the same. So, R prime is equal to 0, and increasing relative risk aversion property would mean that as wealth increases, the percentage held in risky assets basically would decrease. So, that means I am basically being more attracted toward risk, that is I have an increasing relative risk aversion property. In that case, the concept of R prime is greater than 0 would be true. Now, let us come to the utility function, where the actual applications of the utility properties of R and R prime and A and A prime would be important, and you will consider that why non-satiation, why u double prime greater than 0, u double prime equal to 0, u double prime less than 0 would be important as we consider the utility functions. So, we will very simply consider 4 utility functions, and I will appreciate if the students or the participants for this course pay attention to the first utility function. I will come back why it is important later. So, these are basically the quadratic utility function, where it is given by a quadratic form, where u w is equal to w minus b w into w square, where b is a positive quantity. Logarithmic utility function would be given by log of w. W, remember, all these 4 examples or whatever example we are considering are the wealth or the decision variables based on which my overall value increases or decreases. The third one is the exponential utility property, which is minus e to the power minus a w, where a is a positive constant, and power utility function property is equal to c into w to the power c, and c is less than 1 and c is not equal to 0. Now, I will come back to the concept of quadratic utility function later on once again, but I will just briefly mention why quadratic utility function is important. Now, if somebody considers, and that I may not have discussed in much details in this course, but I have definitely done in the other course, which is DADM1. Now, whenever you are considering an estimation problem, what you have is basically trying to analyze the estimate from the sample, and when we take the estimate of the sample, we consider the orderly least square or the OLS concept, quadratic loss functions. Now, quadratic loss functions are easy to handle, their theoretically proofs are very nice, and they give us very theoretically very good results. Another important fact is that if you try to minimize the expected value of the quadratic utility function or the quadratic loss function, it basically gives out the information that is has something to do with the variance. So, trying to basically minimize the expected value of the loss would basically lead us to the fact that you are trying to basically minimize the variance, which is basically the main motivation based on which why it has been considered. So, the quadratic utility function which will be utilized later on would be found out to be one of the best utility functions based on which we will try to do many of our calculations in a very simplistic manner, and I will come back to this later on also. And I did mention, sorry, before I start this slide, I did mention about the loss functions. I will try to bring up some of the loss function which I may have done in DADM1, again bring it back here. So, the many of the students who are doing this DADM2 and not have done DADM1, they may not find it suddenly out of context that those concepts are just being mentioned without being discussed. So, I will try to bring those slides accordingly. So, some examples of the utility functions, which was the first one was the quadratic utility function, it is UW is equal to W minus B into W square. Now, here is where I would like to again bring back the context of A and A prime and R prime. So, if you remember, I have been discussing that, and you may have been thinking what is the importance of R prime, A and A prime. So, what we will do is that we will try to find out the R prime R, A prime A for this utility function, and those values are given. So, A prime is given by 4 into B square divided by 1 minus 2B into B whole square, and R prime is given by 2 into B divided by the same term as it is there in A prime. Now, let us pause here for a few seconds. If you look at A prime, the value in the denominator, which is a square, is definitely positive, and the value which is given in the numerator, which is 4b square, is also positive because b becomes square. Now, if that is the case, it will immediately give us the information that A prime is greater than 0, and then immediately we know what type of property that utility function is. So, let us read it. Hence, we use these utility functions for people with increasing absolute risk aversion property, because that is there for the bullet point 1, which is A prime being positive. And if I consider B as positive or negative, you will basically find out that R prime would also be positive or negative accordingly, because the denominator is quadratic. So, we will say that is increasing relative risk aversion property if B is positive, and relative risk aversion property being negative if we have decreasing one if we have basically B as negative. But in the problem we have already considered that B was positive. So, obviously, it will be an increasing relative risk aversion property. Now, this is the actual information why those relative risk aversion property and absolute risk aversion properties are important, because once you know what type of absolute risk and relative risk aversion properties are true, we will just basically go back and excuse me, and plug in the sense try to find out for which utility functions this is true, and utilize that utility function for the case based on which we are trying to solve the problem. So, that means we may not have the functional form of the utility function, we may not know about the utility function, but we can find out what are the A prime, R prime properties. Based on this, we can comment that what type of utility function it is. That is what the important actual application for our examples for A prime, R prime would be coming out. Now, let us consider an example. Let us consider an example for the utility function, which is the quadratic one. So, you will basically have W's, the values of wealth on the first column as it is given in the slide, because I have not put some values which I will come to in the explanation. In the second column we have the utility function, in the third column we have A, fourth column we have A prime, fifth column we have R and sixth column we have R prime. So, what are the missing columns? I am going to come to that within few seconds. So, the values I have written are the column 3, 4, 5, 6, which is 3, 4, 5, 6. I have put them accordingly. So, they have been calculated. So, how? Let us go one by one. So, first consider the value of W as taken. So, we basically take hypothetical value starting from 2 to 11. So, it can be any values, it need not be integers also, but I am taking them integers. Based on that values of wealth and the values of B which we have considered a value of B. So, B can be found out because it will be, if it is 2, so it will be 2 minus B into 2 square 4. So, it will be basically 2 minus B into 4, which will give us 3. So, from that we can find out what the value of B is, because in that case the second term minus B into W square would be 1. So, 2 minus in the 2 minus 1, wait, it would be, it is taken as positive. So, it is basically we have taken negative values which may not be true, but it can be changed accordingly. So, based on this value we calculate the second column. Now comes the just simple calculations. Now, what is U prime? So, U prime, let me write it down. So, technically U prime is equal to U W by W. So, what you do is that find out the difference of U 2 and U 1. So, this will be second value of U, first value of U, second value of W, first value of W. Based on that we find out the first derivative. So, find out the differences of U's. So, this is U 2 minus U 1, U 3 minus U 2, then U 4 minus U 3, U 5 minus U 4, U 6 minus U 5, U 7 minus U 6, so on and so forth. So, find these values. I have not written them, they would be given here. Now, you find out similarly the difference of W 2 minus W 1, W 3 minus W 2, W 4 minus W 3, W 5 minus W 4, find it out and then divide it. So, once you divide it, you will basically have U prime. Next, you need to find out U double prime. So, U double prime would basically be U 2 prime minus U 1 prime by W 2 minus W 1. So, these values which you have calculated, again find out the first difference, divide by the first difference of W's which you have already got. Find out the ratios, that U double prime by U W, put a minus sign, that will give you A. Then find out the first difference of A and divide by first difference of W, find out A prime. Similarly, once you find out the values of A, multiply by W, you get R, and then again find out the first difference of R divided by first difference of W, you get R prime. So, based on that you can do the calculations. I will come to the graph later on in the next class. So, with this I will end this class and discuss these problems for all the examples for the utility function, and you will find out why the A prime, R prime are important. So, thank you very much for your attention and have a nice day. Bye.